how to calculate the enthalpy change or a missing bond energy. So in this question and this reaction, they give you the energy of all the bonds, but one of them is missing, which is the S double bond O, and give it the symbol X. And they give you the enthalpy change, which is the delta H. We know that delta H, or the enthalpy change, is the energy taken in when all the bonds of the reactants breaks minus the energy released when all of the bonds of the products formed. And in this question, they are telling you that the energy released is 1034 kilojoule per mole greater than the energy needed to break the bonds, which means this is an exothermic reaction and the enthalpy change will be in the negative value. So it's the difference is minus 1034 kilojoule per mole. Now you need to calculate all the energy of all the bonds of the reactants, and here in the reactants we have two SH bonds and they are repeated twice, meaning there are four of the SH bond. And the energy for an SH is 364, meaning we have 4 times 364 plus we have also 3 of the oxygen-oxygen double bonds, which is 498. So plus 3 times 498. So all the energy needed to break all the bonds of the reactants, when we add that, is 2950 kilojoule per mole. And then now you need to find the total energy released for the product. So here from this equation, we can find that the R minus P, as we said, equal minus 1034. So the energy of the total energy of the products will equal the total energy of the reactants, which is 2950 plus the 1034. Now let's have a look at the energy needed for the that released with the product. So here in the product we have two OH bonds and they are repeated twice because there are two moles. So that means in total there are four of the OH and this is the energy needed for one OH. So for the product it's going to be 4 times the 464 plus there is also two SO here, which are repeated twice as well, which means there are four of the SO bonds. So 4x's plus 4x. That will give you the this total, which we should calculate, and that will give you 3,984. So all of that equals 3,984, which means that the 4x equals 3,984 minus the 1,856, which is 4 times 464. So the 4x's bit equals 2,128 and then the x equals 532. So the energy here for the S double bond O is 532 kilojoule per mole.